So hey folks, have you ever wondered how to effectively manage the fluctuating demands of your application while ensuring maximum availability and cost effective? Well, today we are going to explore how autoscaling helps us. So my name is Aditya Tomar and I am an open source enthusiast, and currently I am exploring more about Kubernetes, how it works, what is its architecture. So our agenda for today is what is machine learning? We will look into the Kubernetes, what is the need of autoscaling, what is autoscaling, how does it work, and some of its limitations. Now, what is machine learning? Basically, think of it as like machine learning is allows computer to learn from data without any explicit programming. Machine learning makes decisions by identifying patterns and become better day by day. Imagine like you have an online retail store and you want to optimize your sales by providing personal recommendations to your customers. So what you can do? You can use machine learning to analyze customers' browsing and their purchase history to make sure they get the products in which they are interested. Imagine it like in your daily life you eat an apple to stay healthy. Now before eating an apple, what you do? You wash it, you peel it off, you slice it. Here also we need to clean our data before feeding it to the machine learning model. So we clean it, we have raw data, we clean it, we pre-process it till we optimize it till it satisfies our need before feeding it to the machine learning model. Now where there are various machine learning algorithms like linear regression, logistic regression, KNN, and many more. After feeding it to our model, we train our model, and after that we test our model. Basically, we generally we keep around 70% data we keep for training and 30% for testing. You can also do 80-20. Now let's suppose after training and testing, if it satisfies your accuracy, now let's suppose you need accuracy of 90% but your accuracy comes out to be 80%. So what you can do, you need to tune your machine learning model more, you need to optimize it more, and again you need to train it, again you need to test it. You need to do it repetitively till it satisfies your accuracy. Once it satisfies your accuracy, you can deploy that model on some deployable platforms like Heroku or any cloud platform. Moving on. Now, what is Kubernetes? Basically, Kubernetes is an open source container orchestration platform. It it is used to manage containers at scale. It manages how they run, where they run. It was basically developed by Google in 2014 and donated to CNCF. It has self-healing capabilities. Self-healing capabilities means if you say I need 3 copies of my replicas, then 3 copies will be there. It is also used for autoscaling. We will see we'll see how autoscaling works. Now let's look into the architecture of Kubernetes. So here we have control plane and worker nodes. Basically, control plane is used to manage the states of the cluster, and worker nodes runs the containerized applications in a pod. Now, once a request comes to API server, some request comes to API server. Now, API server acts as the brain of Kubernetes. Every component talks to API server, so it acts as a brain of Kubernetes. Now, once request comes to API server, it does 3 things: authorization, authentication, and admission. Once the request satisfies these 3 conditions, the task of API server is done. Now, scheduler will see which is the best possible node to run a pod. It will allocate that. Okay. Now let's come to kubelet first. Now kubelet will say API server, do you have anything for me to run? It will talk to API server, right? Do you have anything for me to run? This kubelet will also talk to API server, like, do you have anything for me to run? Then API server will tell, yes, you need to run a pod. Then kubelet will, before kubelet, API server will also save it to the etcd. Like only API server will talk to etcd and all other components will talk to API server. Okay, so etcd is just like API server, and other components retrieve and store information about the cluster in etcd. So after that, kubelet will pass the request to the container runtime. Now what container runtime will does, container runtime will start the containers inside a pod. So basically pods are the smallest deployable units in kits which host one or more containers within them. Okay. Now what kubeproxy is? Basically, kubeproxy is responsible for routing the traffic evenly across pods and across the clusters also. Now, what is CCM? Cloud Control Manager. Basically, Cloud Control Manager is responsible for talking to the cloud and gates to perform some actions. And what Control Manager does? Controller Manager is useful for managing the for responsible for controllers that manages the state of cluster. Basically, for example, replica set controller. It is useful for creating replicas. Okay, moving on. Now, what is the need of autoscaling? Basically, let's suppose you create a killer product that has a huge amount of traffic within for that product. Everyone is dying to buy that product. You had a lot of traffic. Now, you can't handle that by manual scaling. You need to autoscale it. It is based on certain metrics like CPU, memory, queries per second. If your CPU is more, memory is more, then you can't handle the large amount of traffic for your application. Now, what is autoscaling? Basically, it does automatically adjust the capacity based on the customer demands. Like if customer wants more resources, it will scale up. If customer does not want more resources, it will scale down, and it works like that. Kubernetes automatically scale up or down. Here we can see there are three types of autoscaler: horizontal pod autoscaler, vertical pod autoscaler, cluster autoscaler. In horizontal pod autoscaler, the number of pods increases. In vertical pod autoscaler, the resources inside a particular pod increases. And in cluster autoscaler, we increase the number of pods as there are no pods within them. We are increasing the number of pods. Similarly, we can scale down also. In scaling down, the pods will decrease. In vertical pod autoscaler, the number of resources will decrease, and in cluster autoscaler, the number of nodes will be decreased. Moving on, some of the limitations of autoscaling are: if you're not having enough resources, you will not be able to handle your workloads. And if predictions are inaccurate, obviously automatically autoscaling will not be able to adjust capacity according to it. Now, some of the key takeaways from this session are: you have learned about machine learning, an intro to architecture of Kubernetes, and how autoscaling helps organizations in scaling up by using horizontal pod, vertical pod, and cluster autoscaler. So thank you everyone for listening to this session, and for further discussion you can join AI/ML channel on our DoK Slack channel, and I recommend you to check out the statistics indicated in the DoK 2022 research report.